Hello, welcome to the video notes for lesson 7-8, and this lesson is all about representing a function. You'll see the notes for this are on page 42 from your notes packet, and let's go ahead and get started. So, the target for this lesson is I can represent a function as ordered pairs in a table, as a graph, and as an equation. So you can represent functions four ways. Each of these ways may be considered a view of the relationship or the relation. When you know one view, you can usually determine the remaining three views. So that's going to be the other piece to this, is you will need to be able to come up with ordered pairs, come up with a table, come up with a graph, or come up with an equation if I give you just some of the information. Alright, so the first example we have is, suppose a car gets 28 miles per gallon. In this situation, distance is a function of the number of gallons of gasoline. Alright, I'm going to move the screen up a little bit so we can see the whole thing. So this is a real world situation, and when we talk about 28 miles per gallon, that's 28 miles for every 1 gallon of gas. And if you ask your parents about what miles per gallon means, some or all of them will be able to tell you, especially if they drive, that a car that's good on gas gets more miles per gallon, and a car that's not as good on gas gets less. Alright, so view 1 is ordered pairs. So a set of ordered pairs, it identifies specific values that satisfy the function. The input is the number of gallons of gas, the output is the distance. So if you look, the first number, 1, 2, 3, and 4, those are all the inputs, those are all the gallons. The second number, 28, 56, 84, and 112, those are the distance, or the miles that you can get for each number of gallons. The second view is in a table. So we have a table of values, and you'll see the heading, same thing. In a table, it identifies specific values that satisfy the function, kind of like points or ordered pairs, coordinate pairs. But it's organized a little bit differently. So we have our input, our x, and that's all of these values here. And you of course can do some calculating from a table. We've got our change in x, and over here we've got our change in y. And so if we didn't have our constant rate of change, we could figure that out from the table. And actually you can figure it out from everything if you know what you're doing. View number 3 is a graph. A graph gives you a visual picture of the function. Now, it's very important with a graph that you understand whether or not you can connect the dots. And basically, you can connect the dots as long as there are values in between. So, if I've got a half a gallon, is there going to be a number of miles that I can go? And the answer is yes. So that's why it's okay to connect these dots, and in most cases it is, because there's going to be values in between. It's continuous. It goes from one dot to the next. At 1.5 or 2.5 gallons, there is a certain number of miles. And then the last view, or the last way we can view this, is a rule or an equation. A function is a rule for taking each input value and producing exactly one output value. So you'll see this equation, y equals 28x. So x is the input value variable, which is the number of gallons. The output variable is y, and the 28, that's our constant rate of change. That goes in front of x. So when we do some practice, you're going to see we're going to be coming up with equations from this information. So it's very important that you are able to come up with the constant rate of change, because that number is used in our rule or our equation. Okay, so let's go ahead and take a look at another example together. This is on page 43. So during 1 hour of walking, you burn 257 calories. The total number of calories burned is a function of the number of hours you walked. Represent the relationship using a table. Alright, so at 0 hours, there's obviously 0 calories burned, so the point 0, 0. This is what we are starting at. So we're going to start at 0, 0. Then we're going to see the table increase by 1 hour every time. And when you do, you go up by 257. So 1, 257. Then 2 hours, we add another 257, and we get 514. I'm going to go ahead and finish the calories burned. Oh, by the way, here is our X, here is our Y. This is our input, this is our output, our domain, our range. At 3 hours, we're at 771 calories. At 4 hours, we're at 1,028 calories. And at 5 hours, we're at 1,285 calories burned. Alright, so now let's finish filling in our coordinate points. So we got 2, 514, 3, 771, 4, 1,028, and 5, 1,285. Okay? Alright, so notice what is happening from the table. We can come up with our equation, which we're going to come up with next. So represent the relationship using an equation. So y equals something. Alright, our calorie burn. That comes from our change in y over change in x. So what is the change in y? Well, this goes up 257 every time. We are adding 257 every time. So change in y is 257 over, and this is increasing by 1 every time. Now, if this wasn't increasing by 1 every time, we would just have to focus on 2 of these points and find the change in y over the change in x, and that would be enough. Alright, so we get 257 over 1, or in other words, 257 calories per hour. Okay? Actually, we already have the fraction bar, so 257 calories per 1 hour. Alright, so our equation then means we're going to plug in this constant rate of change in front of x, 257 over 1, which is 257, times x. So what that means is, so basically our equation looks like this. So our calories burned comes from the number 257 times multiplied by hours. Alright, so now we're going to graph the relationship, and we have all these coordinate points up above that we can put on our graph, and it's pretty simple. So it starts at 0, 0. First point is at 257, which means we're right just maybe a hair above 250 on our graph. At 2 hours, we're at 514, which is again just a touch above 500. 3 hours, maybe a little more noticeably above 750. 4 hours, Again, we're getting a little bit more above, but not too much. Alright, and then we can't fit 5 hours because that's 1,285 and that goes above our graph. So, we're going to connect our points with a nice straight line, and I know my line's not perfect. You know what? I might as well go ahead and use my ruler tool. And if you've got a ruler, straight line tool, go ahead and use it correctly. Alright, and this is what you need to do. Connect them nice and straight and put an arrow. It is continuous. If you only walk for half an hour, you would still burn calories, about half as many. And if you were to continue to walk, it would keep going up. So you put an arrow on one end, but not on the other, because we can't have negative calories burned. Okay? Alright, one last thing before I stop the video. At the beginning of this, I talked about the 4 different ways that a function is represented. So I'll be looking for 4 different volunteers who remember to bring this up in math, that there are 4 different ways, and the 4 different people will each name one of the ways without saying out loud what exactly you're doing. We'll see if the people who didn't do their homework or listen to the video can catch on to what's going on. Alright? That's it. If you have any trouble with this, make sure you come and see me. Good luck, and we'll see you in math.